Hello everybody, Dr. E-Blox here with the E-Blox project of the day. That's right, it's Friday and we are finally going to build our induction spinner. But before we do, just a reminder, please stay at home as much as possible. We're making these videos for teachers, homeschoolers, and parents so that they can teach the fundamentals of STEM and STEAM through E-Blox while safely from the home. Now if you have E-Blox in your home, we encourage you to join in the building and learning fun. And if you're looking to get E-Blox, there are two ways to do it. One, at our website, www.myeblox.com. That's www.myeblox.com. Or contact your local toy store. Okay, call them, email them, look on their website. Look for E-Blox products. You can buy them directly from your stores online, and we will ship them to your house so that you never need to leave the home. All right, so let's get on to our project of the day, where we're going to build this induction spinner. We're going to learn how it works mostly. It's kind of built here already, but we talked about reed switches and we talked about transistors the last two times, which are going to be a big part of that. Today we're going to talk about the inductor module. Okay, it looks like this and it comes in your CB800 set. Now if you see this part number 84, it actually has 4 connection points, okay? But the markings on it, you can see there's a little squiggly mark. That's the inductor. That's just connected to these two. And then there's a marking on it that looks like the same marking as on your reed switch, and that's connected to these two. So there's actually 2 things in this device. An inductor, which you see here, but also a reed switch is in there, okay? Now, inductors, how do they work? It's similar to when we talked about the motor. Remember when we talked about the motor and how when a wire came in and was wound up as a coil, it actually creates a big magnetic field in the motor? Well, that's basically what an inductor does. You can see on the top here, it's just basically a wire that comes in and wound around a bunch of times to make what's called a coil and then goes out. But when current goes through here, okay, it creates a big magnetic field right above that inductor, okay? So now the next thing is to make this induction spinner. We notice this, we call it a windmill, but it's not really a windmill. It's not going to be wind that causes it to spin. But if you look at the edges, they have magnets in them. Okay, the magnets in there also create magnetic fields. And the idea is going to be, if we create a circuit where current flows through the inductor and creates a magnetic field above it, it'll give the magnets a kick that'll keep it spinning. Well, let's see if that'll work, okay? So here, when I plug this in here, I've actually created a circuit now that can cause current to flow through that inductor. Okay, and every time the magnets come around, the magnetic field right above there are giving the magnets a kick, and it keeps spinning and spinning and spinning. That's pretty cool, huh? Now, why did we need the reed switch and the transistor? Okay, if you look at the rest of this circuit, what's actually happening, and I'm going to stop this for now, okay, you see when I disconnect the circuit, it stops spinning. If you look at the rest of the circuit, the reed switch, which is the top 2 connections, is feeding the base of the transistor. Now remember, transistors can act like a switch. And so when a little current comes in the base, that's what allows current to flow through the collector to emitter, and that's flowing through the inductor. So what that means is that the only way that this transistor is on and letting current flow through the inductor to create a magnetic field is when there's current going into the base, and that only happens when the magnet is near the inductor module. Because when it's away from it, there's no magnetic field here. No current into the base, no current through the inductor, no magnetic field. But as this comes down, the magnet turns on the reed switch. That puts current into the base of the transistor, turning it on, letting current flow through the inductor, and creates the magnetic field. Now, why do we got to go through all of this to make it work? Well, why couldn't we just make current flow through the inductor all the time, okay? The problem would be, as this spins, if there's a magnetic field on there, it goes out in all directions, then when this magnet came down, it would actually force it away, okay? And we don't want that. We only want the magnetic field there when it's just past it to give it a kick in that direction. Okay, so this allows us to actually turn on the transistor in the magnetic field only once the magnet gets down to the bottom and needs that kick, okay? And so that's why we have that whole circuit with the magnet and with the reed switch and the transistor in there, and that's how it just keeps going. I mean, it's a pretty complicated circuit, but it's kind of cool to see how all these devices work together and how this thing is spinning without any motors, just electromagnetism. You know, I've been reading about electromagnetism. It can actually cause, this book I'm reading is about electromagnetism and levitation. I just can't put it down. So, okay, well, I think we did it. We built the induction spinner. This was really cool. We learned about inductors today. And next time, we're going to actually start getting into some story block sets, okay? We're going to go to a cave and start exploring things that are near a cave, okay? Until then, stay safe and stay at home, but continue learning with E-Blox.